So hello guys, welcome to lecture number 7 of space dynamics, and today we are going to see all the PYQs from 2007 to 2024, and we'll see all the concepts whatever we have covered till now, and using all those concepts we'll solve many numericals which have come in our GATE exam. So along with the numericals I will tell you the concept behind the numericals. So myself, Ujjwal Srivastava, I am doing my master from IIT Kanpur, and here I have given my phone number. So if anyone wants to any support or any guidance from my side, please feel free to contact on this number. You can WhatsApp me, you can call me anytime. I will be free for you 24 hours. So without wasting our time, let's start the classes, and we'll go from 2024 to 2027. So basically we'll start from 2024, right? So the first question in our 24th paper was this for space dynamics: which of the following statements? So whenever you see is or are like this, so you can understand this is MSQ problem. That means there must be more than one answer will be correct, right? Although in our exam they will tell you by giving the box or a square, or you can say a circle, to defining the MSQ and MCQ. So you will get this. But still, if you want to know, so you can focus on this term is and are. See now, so which of the following statement is or are correct about the satellite moving in a geostationary orbit, right? So see the option 1. Then first you neglect the option by doing this. A satellite is visible from all part of the earth. Is it really true? Whatever satellite is going into the deep space or in our orbit or in our circular orbit, elliptical orbit or geostationary orbit, can you see the satellite? Obviously no. So this will be a wrong answer, right? The time period of any satellite is 90 minutes. It is not. It is also because for revolution the time period for satellite is 24 hours, as I told you right already, in our circular orbit or elliptical orbit, right? So the orbit is circular about the center of earth. It is right, because geostationary orbit is circular around the center of earth. The orbit lies in the equatorial plane. Yeah, it is also right. So there are two options, A and B are correct for this question, right? Second question, actually I have already taken this. Now see this question very carefully. So guys, I'm solving the problems not as a teacher, not as a faculty. I'm solving the problem as a student, because I'm thinking if someone wants to solve any problem by of space dynamics or any subject, and if they see first time of the question, how they will react and how they will approach the question and how they will think. So I'm thinking like a student, not like a faculty. So see, same like whatever I'm saying and whatever I am doing, you can think of like this, because many students think of it and think like this basically. So see, at a point in a trajectory of an unpowered space vehicle moving above the earth, okay, the altitude above the mean sea level is equal. Okay, suppose there is a one earth. Okay, is your earth. So see, vehicle moving about the earth, what type of path it is given till now not mentioned, right? The altitude above the mean sea level is, that means from here to a particular satellite, whatever that is, let's suppose satellite is over here, distance is your h, and that is given you 600 kilometer, okay, and the speed with reference to the coordinate system fixed to the center of mass. That means with respect to the fixed on the center of mass of the earth, the speed of that velocity, or you can say the speed of the particular or satellite is given by your v is equal to 9 kilometer, right? 9 kilometer per second. See, till now, what type of this orbit we don't know. It may be elliptical, it may be parabolic, it may be circular. We don't know, right? Suddenly, randomly, I have drawn this because there is satellite which is moving, of course. So now you see, Earth is 9 kilometer, right? Assume that Earth is a sphere with radius this much. So radius of Earth is also given. Radius of Earth is 6400 kilometer. Fine, it is given. Now, and of course G is given. That means your K square is given. So Gm is nothing but your. You can remember this value 3.986 into 10 to the power of 14, because most of the time, or 99.9% time, it is given only this one, this value, right? Okay. Then now, by G is the universal gas constant, gravitational constant, and m is the mass of the Earth. The trajectory is, he is asking this velocity, this is satellite, or you can say satellite is given, right? Space vehicle, yeah. These space vehicles which is moving with some velocity. That velocity is already given you, right? But what path they are actually in what path they are actually revolving, we don't know. So basically we need to find in which orbit they are actually revolving. So this types of question, whenever it comes for finding the trajectory of any space vehicle or any satellite, so first you find the two things. First you find velocity for orbital, that is your put under Gm by R. So this R is nothing but your Re plus H. Why I am writing this Re plus H means this is your radius of Earth. From here to here, this is your radius of Earth, right? And they are saying above mean sea level, right? Above the mean sea level, that means above the Earth's surface. So this is your height. So from here to here, we already defined it. This is your R. This is your radial distance. So R is nothing but Re plus H. That means R is nothing but your 6400 plus H is nothing but your 600, right? 600. That means I have calculated this. This is around. Let me take calculator. 600 plus 6400. That means 7000, right? 7000 kilometer. Okay. Now to find the VO, that is 3.986 into 10 to the power 14 divided by 7000 into 10 to the power 3. If you find this, you will get around 7.54 kilometer per second. At the same time, you find BP, that means B of parabolic velocity. That is also 2 times of Gm by R. That means 2 times of root 2 times of V naught. This is also, you can say, the escape velocity. Right. So you will get around 9 point something. Yeah, you will get around 9.399899 kilometer per second, right? Now you see, yeah, 7.554 into 2 times. Sorry, it will be 10.6 0.66 kilometer. Now you see, you have three velocity. First one is your b, which is given, that is a 9 kilometer per second. Okay, then your orbital velocity, you can say the circular velocity, that is your 7.54 kilometer per second. Third one is your vb, that is your v escape velocity, that is your 10.66 kilometer per second. Fine. See, whenever you want to find any trajectory of any space vehicles, and if the velocity is given in this particular question, only you have to find these two. And now you see what happens. I'm giving one box. If you must remember this formula, whatever I'm about to give, because it is very, very important. See, the first one is, if VC is less than the V, fine, and this V is one second please. Yeah, what I'm saying is, if this V is given, that is, see, this is your V given, right? If that is greater than VC, okay, and this VC, or you can say the V given, is less than VP, okay, right, like this in a small. See, this B you have given, right, in your question. If that is greater than the V circular, at the same time this B given is less than your VP, then that path is called as an elliptical path. Right? At the same time, if you can say 2 number, if this B given is greater than the VP, that means obviously this V given is also greater than the VC, so that will be your hyperbolic. Orbit, you can say. Fine. You must remember this formula if the velocity is given in the question, and if the trajectory has been asked in our question, then you must remember this formula and recall this formula at that particular time. So now you can find your answer, that is, this B is given is greater than the VC, fine, and this is less than the BE. That means our answer will be elliptical. This is your answer. Fine. Next question I want to take is, let me take the next question. 60. Yeah. Let me take question. Yeah, this one. Hope it is visible. Yeah. Now read the question. Now draw the diagram too. Whenever question is given, draw the diagram. Consider an artificial satellite moving around the sun, moving around the moon in an elliptical orbit. Let's suppose this is your moon. right? One artificial satellite is moving around this moon in an elliptical orbit, right? Let's suppose this is your satellite. Satellite. So it is having some velocity, of course. So the altitude of the satellite from the moon surface at the perigee is that much. So let's suppose from here to here, this is your RP. We have drawn this diagram very neatly in our note, and this is your, let's suppose this is your, of course, RA. Okay. So this given you RP is a 25 kilometer, okay, and that at the opposite, that means the RA is given as your 134 kilometer. Fine. Assume that the moon is a spherical with radius, that means, so radius of a moon is given as 1737 kilometer. Fine. Now you see the trajectory is considered with reference to the coordinate system fixed to the center of the moon. Okay, that means frame of reference is fixed. The ratio of what he's asking is the ratio of the speed of the satellite at the perigee to the at the apogee. That means V of P divided by V of A. So in the last class, I have given you the formula for BP and BA, if you remember. BP and BA, right? This is both formula, BP and BA. So we have to calculate this BP and BA. But before, okay, write the formula first. BP is nothing but your GM by A 1 plus eccentricity 1 minus eccentricity, right? That is okay. If you give the BA formula also, this GM by A into 1 minus E divided by 1 plus E. So if you divide these two, so this and this will be cancelled out. If you divide this, right, you will get only VP by VA is nothing but root under 1 plus E by 1 minus E divided by 1 minus E divided by 1 plus E, right? So you will get root under 1 plus E to the whole square divided by 1 minus E to the whole square. When now we need to find the eccentricity first. So I told you, whenever you have we have to find the eccentricity, we need to remember this formula. This formula, right? I told you. So you are having RA and RP, you are having in your question. But the catch is that E is nothing but your RA minus RP divided by RA plus RP, right? Catch is that you have to put this RA in terms of radius. That means your RA is given as 25 kilometer, and RP is given as 134, I think, yeah, 134 kilometer. So never, I'm writing here, never use this given RA and RP value. So now what to do? You have to add the radius, because see, our reference frame is fixed. See here, with the reference of the coordinate system fixed to the center of mass of the moon. That means here. So, and we are taking only from distance from here to here. So that is not a point. That means our calculation will be wrong. So we have to take from here to here distance. That is why we have to add the radius of the moon in the RP value and RA value. So RA will be your 35 plus 1737 and RP will be your 134 plus 1737. That is equal to 1762 and that is equal to 1871. That is kilometer. Now you can put this RA and RP value in this. You can get the eccentricity value. So now put. So E is equal to 1871 minus 1720 divided by 1870 plus 1762. You will get eccentricity as a 0.030. That means it is obvious, right? Because in our question already it says that it is elliptical orbit. That means eccentricity must be less than 1, and when we found our eccentricity, it has come less than 1. That means our approach or solving the problem approach is correct. So now you can put this E value in our equation. So this Vp by Va is nothing but your 1 plus 0.03 to the whole square and 1 minus 0.03 to the whole square. If you calculate this, you will get as a 1.06 answer. So what he has asked, rounded up to 2 decimal places. So if he is asking up to 2 decimal places, we have to write at least 2. More than 2 we can write, but at least 2 we have to write. Otherwise they will not give a mark. They will put 0 mark. So we got 1.06. So we'll put 1.06. This is the answer. Fine. So let me check next question if there is. No. So 2024 is over. Only 3 questions has come in this we can say year. Now we go for the 23. So let me take the question. I heard 23 gate was a very tough exam, or you can say the paper, because whenever Kanpur take the paper for the gate, it makes sure that it is not very tough, but it is literally tough, moderate to tough, you can say, not easy to moderate. So now you see the question. Let me see the 63. 63, this one. Asking the satellite emergency level. Okay, altitude is asking. Okay, let me take. This is a question. Let's take here. Hope it is visible. Now see the question. Solution, of course. See, A satellite is in circular orbit. Okay, suppose there is a around the earth, that means here is the earth. Always draw the schematic for any question for any subject. This is your earth and there is a circular orbit around this earth. Fine. Okay, there is a circular orbit around the earth. So suppose this is your satellite. The time period is 90 minutes. That means the time period for the satellite to complete one revolution is 90 minutes. The radius of Earth, that means R of A, is equal to 6370. And one thing also I am telling you, whatever values are given in the question, only use that value. Never use your own value or whatever you have marked up in your class or in your note, whatever you have written in your notes. Don't use that value if the values is given in your question. Use that value only. Yeah. So now mass of Earth 5.98 into 10 to the power 24. Fine. G is nothing but your 6.67 10 to the power minus 11. Right. He's asking the altitude. He's asking the altitude of the satellite above the mean sea level. That means he's asking this H is R. So he is asking the altitude of the satellite above the mean sea level. That means he is asking this H. Understood the problem? Now you write. So first you tell me what is formula for time period in circular orbit. That is your T square 4 pi square A cube divided by GM. And if you just multiply this, you will get around 3.986 into 10 to the power 14. So this is your, so you know that this A, or you can say R, of course, this RE plus H. That means first we find this A, then we'll subtract this RE value, we'll get this H. That means this H is nothing but your A minus RE value. Right? Let's find the A value. For finding the A value, we need to convert this time, which is given in minutes, to second. That means 90 into 60 will do in second square 4 pi square A cube GM. That means we will get A is equal to around 6649213, right? Obviously in kilometer. Now that is equal to RE plus H. So that is why I think it is in meter. Yeah, it is in meter, I think. So H is equal to, this value is nothing but your given 6370 kilometer, that is converted into meter power 3. That means 6370123. So if you subtract the value 6649213 minus 213 minus 6371234, you will get around 279 2.3 kilometer. So if you, in our question, see, in our question, whatever they are asking, whether it is kilometer or in meter, we have to fill only this. So they are asking in kilometer, so you have to convert this meter into kilometer. So divide by 1000, of course. So H will get this 279 kilometer approximately. So they, of course, they might have asked nearest in the year, so you can write 279. Right? Again, the next question is also given 62, 62, 62. Yeah, this question. It is very easy, yeah. Now we read this question. Hope it is visual. The universal gravitational constant is given. Okay, for a planet of a mass is given. Okay, radius is given. So what is escape velocity? Escape velocity. So here there is nothing called any circular orbit or any elliptical orbit. They're only asking the escape velocity. And also in this question they are not mentioning any orbit, whether it is circular or your elliptical. So first let's understand what is escape velocity. It means, let's suppose this is your earth, right, and around the earth there is a earth gravitational field, you can say. This is your earth gravitational field, earth gravitational field, right? So at what velocity I throw anything, any object to cross this or escape this gravitational field, that is called the escape velocity. If you are throwing any object which is less than the escape velocity, or escape velocity is nothing but your 11.2 kilometer, right? That means if you are throwing any object of 11.2 kilometer, that will be cross the gravitational field and that will go into the space of you, obviously, right? If you are throwing any ball or any object less than this velocity, so it will come to the earth again, or earth surface again, right? So they are asking what is the escape velocity if the mass and everything has been changed. So B is already have given formula 2 times of Gm by R, right? Okay, so here in our question the H is not given. That means from here to here the H is not given. That means the R is your RA basically. So B is nothing but your 2 times of 3.987 or 986 into 10 to the power 14 divided by radius, that is 3390123. So you will get around 5.025 kilometer per second. So here is asking up to the 1 decimal, that means 5.0 is option. So 5.0 kilometer per second is the right answer for this question, right? Okay, let's go to the GATE 2022. Yeah, so in GATE 2022 the question is 46. Okay, let me take the 46 question. I'm going very slow because of to understand the concept as well as the problem. If I can able to solve the problem very quickly, but I have given already the exam and cracked the exam and into IIT. You have to understand the problem and you have to build your approach, how to approach the question and how to understand the question basically. If you understand the question very carefully and very neatly, and if you are able to draw the diagram or free body diagram or any diagram of the question or a schematic, you will be solve most of the problem very quickly. That is why I am focusing on the build your concept. So the 46, let's see the 46. Yeah, this is a question. We take this. Hope it is visible. See, it is also a MSQ problem because already I have told you is there true or something. So it is asking what is a true. So here, see the first option. I told you this is a formula for a trajectory equation, or you can say the conic equation. So we have already studied R is nothing but your P divided by 1 plus E cos theta minus E cos theta minus E, right? This P is nothing but your H square divided by K square, right? And this K square is nothing but your GM. So the right formula is R is equal to H square divided by GM into 1 plus E cos theta minus E. But in question what is given? Let's see. Considering the high Earth orbiting satellite is H1, okay? Eccentricity is E. The mass of the Earth is M. G is a constant. The distance between the satellite center of the mass and is given the R, okay? The truly enemy is a theta, okay? The phase angle is 0. That means this angle C is given as a 0. That means only cos theta. Fine. The phase angle is 0. Which of the following is a true or true? So is it true? It must have a square, right? So this is wrong. In second option you can see the H square divided by GM 1 plus cos theta C, theta you can say. So H square GM 1 plus cos theta, that is a correct. As I told you, the H is a conserved. That means I have told you this H is nothing but your angular momentum per unit mass. Right. And angular momentum is conserved. This is your conserved. Right? So that is why this H is conserved. It is also correct. Conserved means it is not changing at the time. Right? Similarly, the sum of potential energy and kinetic energy of the satellite is conserved. Is it true or false? See, the sum of potential energy and kinetic energy, what is given is, that is your E of T you can say. That is your total energy, I think. Yeah, total energy. Right. That is equal to sum of kinetic energy plus potential energy. I have told you already, right? So it is also constant. With one formula I have got like this: 1 by 2 B square minus G M by R, that is equal to constant, something we got, right? If you remember. So that is also constant. That means this is also correct. So the option 4 get 22 this problem is A is not correct, B, C and D. Answer right? Okay, next question is, yeah, only one question for 2 marks it has come, I think. Yeah, for 2 marks. Let's go. And there is not any another question in 22. Let's go for 21. In 21, question number 25. 25, yeah. Yeah, this question. So let's start for the 21. Let's see. Solution for this. The velocity required to launch a space vehicle from the surface of the earth, okay, to achieve the circular orbit. That means is the earth to achieve the circular orbit. Right? So how much velocity you need for achieve the circular orbit? That means this velocity you need to find this circular orbit. Radius is given also over here, and it is given. So you need to find the circular orbit. So V is nothing but your Gm by R. This Gm is nothing but your given as this much. So it is nothing but your 3.986 into 10 to the power 20 14 divided by R is nothing but your 250 plus 6378.14 into 1000, because we are converting this kilometer into the meter. If you calculate this, you will get P orbital is equal to around 7754 meter per second. See, in the question they have not asked in any unit in meter per second or kilometer per second. So you can write your answer as a meter per second or kilometer per second. Both are the correct. So your answer is 7754 or 7.754 kilometer per second, meter per second. Fine. Okay, let me take next question. Yeah, in 2021 also there was only one question for 2 mark. I think 2 mark or 1 mark. Yeah, let's go for 2020. Get 2020. Get 20. So let me take a water, please. Number that means 20 11 let's face 11. Yeah, this one. See, question is saying is for hyperbolic trajectory, right? Hyperbolic of a satellite of mass m having the velocity v at the distance r from the center of Earth. Okay, g is given, m is given. Which of the following is the following relation is true? He is asking, right? So what is this? This is your kinetic energy. This is your potential energy, right? So for hyperbolic trajectory, the eccentricity must be greater than 1, okay? The total energy must be greater than 1, okay? So the total energy is nothing but your half m p square minus gm m by r, right? That is greater than 1, is it? So 1 by 2 mv square is greater than gmm by r. So which of the following option is correct? I think option 1. That means option A is correct. So in 2020 also only one question. Go for the 19. In 19 there were all, I think only one question. Let's see, 2020 42 or 52. Yeah, this one. So 19, come to 19. If I miss any of the question in any end, so please go through this and you can solve this problem very quickly and very easily, because all the things already I have taught in our class, right? So yeah, see, it is very cheap type of question you can solve by your left hand only, I can say. Yeah, asking the product of the mass and the g is given as this mass. That means gm, that is equal to k square, is equal to given as 3.986 into 10 to the power 14, right, is given. The radius of the earth is given, so r is given also. Always write a data, whatever is given, write data in your note first, then after you can understand how to approach the problem. Now it is asking the minimum increment in the velocity to imparted to a spacecraft flying in a circular orbit. That means this is your earth, this is your circular orbit. So already is saying the minimum increment in the velocity to impart it to a spacecraft flying in a circular orbit. That means already the spacecraft in this orbit, right, which is revolving with its velocity around the earth at an altitude of 400. That means from here to here is h. H is given as a 4,000 kilometer. Now we are asking to make it exit earth gravitational field. That means I already said here I already said here, to escape from the earth gravitational field we need to have the escape velocity, right? So same thing is asking here, make it to exit earth's gravitational field is. That means if you want to this satellite, or you can say any spacecraft, to exit from the earth atmosphere, or sorry, earth gravitational field, then we need to find the VE, right? So what is the required minimum increment in the velocity? Already it is having some velocity in the circular orbit. Understand this problem very quick, very carefully, right? It is very important. See, probably what happens, earth is given, right? Earth is having some circular velocity or circular orbit in which one spacecraft is flying already with some velocity, right? We want to escape this orbit or circular orbit and travel into the deep space, we can say. So we need to escape this gravitational field of the earth, right? So I want the minimum increment in the velocity. So already we are having some velocity, so how much velocity I need to have to escape this circular orbit and go into the deep space? That means the difference of this both, is it? That means minimum velocity is asking, right? That is why delta V, that is your excess velocity, you can say, V escape minus V orbital. So V escape is nothing but your root under 2 times of Gm by R minus Gm by R. So you can take root 2 minus 1 into Gm by R to the whole square, or 1 by 2. Find this Gm by R, keep the values, all the values. So it is given as 9.86 into 10 to the power 14 divided by 6371 plus 4000. 6371 plus 4000 into 10 to the power 3 to change into the meter, right? 1 by 2, root 1 2 minus 1. If you find this or calculate this value, we will get delta V as a 2 point I think 2.57 Let me check. Let me calculate this. 9.86 into 10 to the power 14 divided by 3 divided by 6371 plus 4000 0.5 into root 2 minus 1. Yeah, so you will get around 2.567 kilometer per second. So you can go and fill here, round it up to the 2 decimal, that means 2.56 kilometer per second, right? This is the question. So I think, yeah, there is only one question, 19. Let's go for the 18. So this video is a little bit longer, but still I want to finish this chapter because it is okay. So 44 the question number. Let me go to the 44 spacecraft. Okay. It's a very cheap type of problem, you can say. You can take 2 marks very easily and 3 marks very easily in our exam. Previously, that means before 2 or 3 years, the question was coming very less for only 2 mark or 1 mark, but nowadays the questions are coming regularly for the 2 or 3 marks for space dynamics. So you can easily score 2 to 3 marks for sure. Understand the problem. Now, the spacecraft form a circular orbit in an altitude. That means spacecraft is forming, there is the Earth. The spacecraft is forming some circular orbit, right? Suppose this is a circular orbit, this is a spacecraft. Having some h is equal to 150 kilometer. Fine. It means h is nothing but your 150 kilometer. Okay. Now the surface of the spherical Earth. Okay. The radius is given also. So r is given as your 6400 kilometer. Obviously, this assume the gravitational parameter. Whenever you are given the mu value, that means mu is nothing but your GME, that is equal to k square. It is always constant 3.986 into 10 to the power 14, right? So the velocity required to injection of the spacecraft, that means how much velocity I need to require to inject this aircraft. That means the aircraft is flying in this, or you can say the forms a circular orbit. It is forming a circular orbit. So how much velocity we need to inject to stay in a circular orbit? That means he is asking the velocity of a circular or orbital. So please take the formula and keep the 9.86 10 to the power 14 divided by 6400 plus 150 into 10 to the power 3. I am using this formula, Gm by R. This R is nothing but your Ra plus H. Till now you have to remember this formula. B0 you will get as a 7800 meter per second. In question is asking in, again it is not again it is not the mention, here is not mention the unit, so you can write in kilometer or meter per second. It is up to your choice. His answer is this one. Okay, only one question in 18 also. Let me go for the 17. In 17 the question is 14. Yeah, this one. So 17, one second. The question is 14, that means, yeah. Hope you can see the question. Yeah. start. See what happens. The period of revolution of Earth about the Sun. Okay, there is a Sun and Earth is revolving it. This Earth is revolving it. Okay. So the time period of Earth to revolve this Sun, it takes the 365.256 days. You know already in 1 year, the Earth revolves one time of the Sun. Okay, approximately. The semi-major axis of the Earth orbit is close to this much. That means E of Earth is equal to 1.4953 into 10 to the power 11 meter. Okay. The semi-major axis of a orbit of Mars is this much. That means orbit of Mars you can think what you 22783 into 10 to the power 11. That means the Mars is also revolving this Sun. This Earth can come like this, or it can be different orientation. Let's see. So this Mars is also having the major axis. So now it asking the time period of revolution of Mars about the Sun is. So how many days the Mars will take to complete one revolution of a Sun? So as I told you, whenever you have given the time period and the semi-major axis, so remember Kepler's third law. So what Kepler's third law says? It says that the time period of any satellite, the square of the time period of any satellite is proportional to the q of the semi-major axis of the particular satellite. So this is your Kepler's third law. Right. So now you write. Let's suppose I am supposing this as a 1. Okay, sorry. What happens? Sorry. So let me take this one as a 1 and this one as a 2. So T1 by T2 square is equal to A1 by A2 square. Sorry, A2 cube. So you need to find the A2 value, right? That means T2 value you need to find. So T1 is given as days 365.256 divided by T2 value to the whole square. Right? A1 value is given 1.4953 into 10 to the power 11 divided by 2.2783 into 10 to the power 11. That means whole cube. So if you solve this, we will get this T2 as 686.9 days. How you will solve? You will solve this. You will solve this. Then after take this. How you will solve? You will solve this. Then after you take this square into the square root, and then after find a T2 value, you will get this formula. You will get this 686.9. So in decimal 3 places, so 686.9, or you will get something 48, something like this. So you will get this one. So okay, so it's a 1 hour. So still we are having the at least 10 problems. So we'll do next lecture for the rest of the problem. It takes around 30 minutes to 40 minutes. So till now we have solved the problem of 17. So in next lecture I will solve for the 16 to 7. So mostly I think 10 problems are there. We'll solve within 30 to 40 minutes and we'll wrap the class. But now I'm solving all the problems by understanding. I'm not teaching you as a faculty, I'm teaching you as a student. Whatever I have to think in first time, the same thing I'm teaching you as a whatever I was thinking my first time. The same thing I'm thinking to teach you like this, because the first time whenever you see the problem, you will face the same problem whatever I have faced most of the time. So that is why I'm teaching to understand you like a student, not as a faculty or teacher or something. So practice this formula till now. I think you might have solved all the formulas without seeing the solution, but still it is my duty to solve all the problems of the PYQ. So till now, thank you so much for being patience, and you can go through this solution for the different previous year problems for the space dynamics, and I'm planning to do the next subject as a thermodynamics, or I think rocket propulsion, because one part of the propulsion has to be finished, and these are the very independent subject, the space dynamics and rocket propulsion. So little bit the gas dynamics and propulsion will come, but still we'll talk about this in detail. We will discuss the propulsion or something. So we'll start the rocket propulsion in the next, you can say, the chapter or subject. So thank you so much for being patient. You can contact me on my number always, and study well, and please subscribe my channel and share to your colleagues and friends whoever needs this lecture, because when I was preparing for my GATE exam, so I was trying to lectures on YouTube, but it was very difficult to find the suitable videos or suitable lecture for any subject in a systematic way. So that is why I'm planning to give all these chapters or subject in a systematic way, so that no one can face the problem which I have faced already. Thank you so much for being patient, and let us see in the next lecture for the space dynamics. Thank you so much.